All right, rate of change, problem, rate of change, radius and area of a circle, between radius and area of a circle. All right, suppose we have in the sea or a lake or some small pool or something. I did throw a stone. What will happen? If we did throw a stone, first we see this circle of it happens like it goes like that, right? A circle. Suppose that this circle of radius r equal, let's say, 3 centimeter per second, right? Suppose this radius is, sorry, the radius is 3 centimeter. The radius is for sure 3 centimeter. Suppose the radius of this is 3 centimeter. But what happened after that? After that, I can see that this wave is going bigger in circles, right? And bigger as time moves, right? So the radius will be also larger, and suppose we have that this radius is growing at a rate. This radius is growing at a rate of 1 centimeter per second. Suppose this is the rate of change of r. So what is this centimeter is the length of the radius, and second is time. So simply, and this is the change, rate of change, right? It's the increasing of radius in terms of time. So we can have that, we can say that the r over dt is equal to 1 centimeter, right? Is equal to 1 centimeter per second. So also 1 centimeter per second. Also, this is a given. Okay, what will happen then? He wants me to find, he's asking me to find at what rate is the area of the circle, growing? At what rate is the area of the circle growing? We know that when the radius becomes bigger, right, larger, the area will become also, the area of the circle will be more and more, right? This was the area, and it will increase. The area will increase more and more and more as the radius increases, right? As the radius increases. So let's say we want to find dA, the rate of change of area in terms of time. So what is that? Let me first find the unit. What is the change of area? If the radius is centimeters, so it will be in centimeter square, and time will be in seconds. So finally, we are talking about what? We're talking about how many centimeters square per second is the change of this area. This is nice. So if I take dA over dt, right? If I take dA over dt, we need to find it. What is dA over dt according to chain rule using radius, because we have a relation between the area of the circle and its radius. It's simply dA over dr times dr over dt. This value here, dr over dt, we already have it, right? We already have it. I have no problem. It's 1 centimeter per second. Then what I'm looking to have now, dA over dr. Can we find dA over dr? First, what is the area? What is the area of the circle? Do we have a relation that gives me an area in terms of radius? For sure. The area of a circle is given as pi r square. This is, we know about the area. Look how nice if we differentiate both sides in terms of r, right? We are finding area here in terms of r. So I want to find the derivative of area, as a function of r, right? In terms of dr. So it is as a function of r. So here r acts like x in y equal equation function in terms of x, and a acts like y. What is this derivative? It's the derivative of pi r square to dr. And what is derivative of pi r square? Let me first, pi is a constant, so I'm finding just derivative of r square to dr, right? What is derivative of r square? It's 2r. And times pi over here, it's 2 pi r. What is 2 pi r, by the way? It is the circumference of the circle. This is the circumference of the circle. So if we derive the area of the circle to the r, simply we find the circumference of the circle. Now, we have now the a over the r, but do we have r? Yes, r is given given as 3 centimeter. If you remember here, r is given as 3 centimeter. This means we can substitute. So the a to the r equal 2 pi r, which is 2 pi times 3 centimeter. I ended up with 6 pi centimeter. This is the area of the circle. This is the derivative of the area of the circle when r equal 3 centimeter. Now back to my chain rule. We need to find how much the area of the circle in terms of time changing, growing, because the radius is growing into more wide circles, more larger circles, right? So the a over the r, I found it. I just found it, which is this the a over the r. We just found it. It's 6 pi centimeter. And the r over dt, we have it by the beginning, because the r by dt is radius changing as 1 centimeter per second. Each second it's growing by 1 centimeter, so 1 centimeter per second. The units are very important here. So what is the a over dt? It's 6 times 1. It's 6 times 1, so it is 6, right? 6 pi times 1. It's 6 pi centimeter square per second, right? Again, let me see. Yep, that's it. That's it. So 6 pi centimeter square per second. And I'll see you next video, also about rate and area.